All right, so we're going to look at the last part of section 4.4, which gets into sketching graphs by hand and then solving radical equations, okay, with algebra. So the first thing that we always want to do when we are sketching a graph is find the point that would have been at the origin. For an even root, this would be what I call start point. If it was an odd root, then the point that's at 0, 0, I would call it the center of the graph. But either way, whether it's an odd root or an even root, you need to find the new start or the new center point for your graph. Does everyone understand that you don't have both in the same graph? You have one or the other. So whichever one you have, you need to find it. And the way that you find it is first you're going to find the x value. Since we're finding a coordinate, we have to find two numbers. We have to find the x and we have to find the y. To find the x, you're going to set the radicand equal to 0 and solve. Just as a reminder, that part is the radicand. So the only thing that would affect the x value is the a and the b. The c and the d have nothing to do with the x value of your new start or center point. So set the radicand equal to 0 and solve. Once you do that, you're going to have a number for x. You can take that x value, let's say you had something like this. Once you do the first part, set your radicand equal to 0 and solve, then you're going to have a number you're going to be able to plug in right there. When you plug in that x value and you do out all the math, it's going to give you the y value. So you find the x value first, and then you substitute it into your formula, and then you'll have the y value. Okay, now that's not the whole graph. That's just where the graph is either going to start or that's where the center is going to be. After we find that point, we need to get some more points. If it's an even root, that's easier. Because all you have to do is check a few points in one direction, like that. If it's an odd root, then you're going to have to check points in both directions, to the left and to the right. Because your graph has to be drawn in both directions. Okay, so let's try this one. Okay, so first of all, is this problem going to have a start point? Or is it going to have a center point?
A center point.
Yeah, it's going to have a center point. So to find the x value of the center point, set the radicand equal to 0 and solve. Okay. What's the radicand in this one?
Of x. Like, wouldn't it be like a 3 minus 2x?
3 minus 2x. So it says set the radicand equal to 0 and we solve. So we're going to get 3 equals 2x. And how would I get x by itself?
Divided by 2.
Divided by 2. So x equals 3 over 2, 1.5. So that's the x value of my center point. Now I need to find the y value. Okay, so take your x value, plug it back in, do it out, and then you'll get the y value. So let's plug in 1.5 or 3 over 2. What's 2 times 1.5?
3.
3. And what's 3 minus 3?
0.
0. It should be 0 because that's what you set it equal to. If you plug it back in and you don't get 0, then you solve this wrong. Okay. So we get 0. What's the cube root of 0? 0. And what's 0 times 2? Still 0, and then plus 1. 1. So the y value is basically what's right there. So that is my new center point, 1.5, comma, 1. Okay. So now, let's graph it. Okay, let's make it all bigger. Okay, so 1.5, comma, 1. 1.5, 1. So there's my center. Now, because it's a center point, do I check points on one side, or do I check points on both sides? Both sides. And the quickest way to check points is to plug that in and use the table. I don't have to use a table, but it's faster. So we're going to do 2, and then make sure you put in the times symbol. Even though I don't have a times symbol here, you need to put one in, because you've got to separate the 2 from the index, and that's what needs to be typed in next. So 2 times, and that 3, it's not going to be 2 times 3. Once I press math, option 5, it's going to turn that 3 into an index. Okay, so 2 times the cube root of 3 minus 2x, and when I do the plus 1, make sure you press the right arrow, so you get out from under the root, and the plus 1's on the outside. Okay, so that's how you type it in. Now let's do second table, and let's check our center. When I type in 1.5, did I get the same y value? Yep, so the center is good. Now what I usually do is check 3 points to the right of the center, and then 3 points to the left. You can check as many points as you need to make a picture. Okay, I would do like 4, 8, 10. Let's do like 0, -5, -10. It doesn't really matter which ones you use. But I'm only going -10 to 10. That's the size of my graph paper. So let's put that over there. And now sketch all those points, and we should get a nice curve. So 4, about -2.5. 1, 2, right there. 8, we're at about -3.7. 1, 2, 3. 10, we're at just past -4. Okay, so that looks pretty good. 0, we're at 3.8. So about right there. -5, a little under 6. 1, 2, 3, 4, 5, 6. And -10, a little above 6.5. 1, 2, 3, 4, 5, 6.5. Yeah, looks pretty good. Okay. And then just draw. I can do better than that. If I make it so I can just see it better. It's like this. Where'd it go? Oh, there it is. It's easier for me to draw it when it's a little bit smaller. That's basically what your graph should look like. Okay. Any questions on that? All right, so that's a cube root. Goes in both directions. Let's try this one. Is this graph going to have a start point or a center? Yeah?
Start point.
Yeah, it's going to have a start point because it's an even root. So this one's only going to curve in one direction. That means if you plug in points in your table that go the wrong way, you're going to get an error because they're going to be imaginary. So now we've got to make sure we pick points that go in the correct direction. All right. What's the equation that I would set up to find the x value of my start point? Yep.
4 minus 3x equals 0.
4 minus 3x equals 0. we get 4 equals 3x. And that means x is going to equal 4 over 3. Okay, so there's my x value. Now, when you take 4 over 3 and fill it back in, what's 3 times 4 over 3? Yeah. 4. And 4 take away 4? 0. 4th root of 0 is 0. And 0 times 3? And then minus 2. So the y value is negative 2. That's my start point. Okay. So let's get a graph. There. And see what we can do. So 4/3, that's 1 1/3. So we're going to go right 1 1/3, down 2. 1 1/3, down 2. Now we only have to check x values in one direction because we said that's a start point. Let's try values that are bigger. Let's try like 10. Okay, that's definitely a bigger value. If you plug in 10 for x, what's 3 times 10? 30. And what's 4 take away 30? Negative 26. Can you take the 4th root of a negative number and have it be real? No. So plugging in numbers that are bigger than 4/3 isn't going to work. We need to plug in numbers that are smaller. Like an easy one to do would be 0. If you plug in 0, what's 3 times 0? 0. And 4 take away 0? 4. That's a positive number. That's going to work fine. So to do that a little faster, we're going to use the table. And we want 3 times the 4th root. So actually, I can just modify what I have right here. So 3 times the 4th root of 4 minus 3x minus 2. So I like to just check the start point. Let's do 4/3. And yep, 4/3, we get negative 2. Notice what happens if you try plugging in numbers bigger than 4/3. Bless you. You can't do it. Plugging in numbers bigger than 4/3 gives you imaginaries. If we plug in numbers smaller, I think we can use those same numbers. Those are fine. 0 is, let's put this up here. So 0 is 2.2. Negative 5 is 4.2. 1, 2, 3, 4. And you should notice it's starting to level out. And negative 10 is 5.2. Looks a little and dry perfect, I don't think, but it's okay. Kind of like that. So that's how you sketch an even root. Any questions on that one? Okay, so even root, and the last one was an odd root. So now when we do some sketching, that hopefully should help a little bit. Yeah, you know a little more what you're looking for. Okay, so the last thing, solving radical equations. So we're going to be solving equations that have roots in them, okay, and getting the x by itself. The most important thing that we need to do when we are solving radical equations is to make sure that the radical is by itself. So when I say isolate, I mean to get the radical alone on one side. This is an example of a radical that is alone on one side. That's good. This is an example of a radical that is not alone. That's not good. Okay, so our first step is to make sure the radical is alone on one side. Once we get the radical alone, then we're going to get rid of it. The way you get rid of it is by raising each side to the power of the index. What kind of root is the one on the left that has the green check mark? It's a square root. What is the index on a square root? It's a 2. So what we would do in this problem is raise each side to the second power. So raise each side to the power of the index. We do have to check for extraneous solutions, make sure that the answer we have works when you plug it back in. All right, so we'll try a few examples of that. That'll be it. So we're on example 4. Okay, so solve algebraically, but I am going to make up a different question. All right, so let's start out with something like this. Square root of x minus 2 equals 5. Okay, so this would be considered probably the simplest type of equation with a radical that we're going to do. So the first step, isolate the radical on one side. Is the radical by itself here?
Yeah.
Yes, it is. So now, raise each side to the power of the index. What's the index on that root? 2. So we're going to raise each side to the power of 2. When you have a square and a square root, what happens with those two things? They cancel out. And what does that leave you with on the left side? X minus 2. And what does that leave you with on the right? 25. And now we just get x by itself. So my last step. Plus 2. Okay, let's plug it back in and see if it works. What's 27 minus 2?
27 minus 2.
Yep,
25.
25. And what's the square root of 25?
5.
Yeah, so that works fine. Okay, so already isolated, answer works, we're good. All right, let's try this one. Let's try 8 times the square root of x minus 4 equals, let's do 80. Okay, so first step here, is the radical by itself? No. So what do I have to do on both sides to get the radical alone first?
Yeah, divide by 8.
Right. I'm going to divide each side by 8. Those cancel. And I've got square root of x minus 4 equals, what's going to be on the right side? 10. Now we can do it just like the last problem. What would be my next step on both sides? Yep.
Square root of
Yep. I'm going to square both sides. Square and square root cancels out. We get x minus 4 equals 100. And that would mean x would equal 104. Yep. So a little bit more work than the last one, but not that much more work. And if you plug that back in, it does work. Any question on that one? All right, let's try this one. Let's see. try 6 plus 3 times the square root of x, let's do 2x, plus 5. Let's have that equal, let's do 3. Okay. Is the square root by itself this time? No. So what's my first step? Yeah? Yeah, I'm going to subtract 6 on both sides. That's gone. So we get 3 times the square root of 2x plus 5. And 3 minus 6 is negative 3. Okay, is the square root by itself now? Nope. What do I do at this step? So now we're going to divide by 3. Divide by 3. And what's negative 3 divided by 3? Negative 1. Okay, is the square root by itself now?
Yep.
Okay, so now what would I do on both sides? Raise it to the power of 2. Square and square root cancel. Plus, so you get 2x plus 5 equals 1. What's my next step? Minus the 5 on both sides. And that gives me 2x equals negative 4. And my last step? Okay, so divide by 2. And what does that give me? Negative 2. Now let's check that. Let's see what happens. Okay. We plug negative 2, I'll rewrite the original problem. Let's see if that comes out to 3. Okay, if we plug in negative 2, what's 2 times negative 2? Negative 4. What's negative 4 plus 5? That's 1. And the square root of 1? 1. 1 times 3? 3. And 3 plus 6? 9. So what were we supposed to get? We were supposed to get it equal to 3. All right, so let's just make sure we did it right. Plugged in negative 2. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. Square root of 1 is 1. 1 times 3 is 3. 3 plus 6 is 9. Okay, well, let's graph it. Let's put the left in y1, and let's put the right in y2, and see if we can see where they cross. So 6 plus 3 times the square root of 2x plus 5 and 3. Wherever they cross, that should be the answer. Let's do zoom 6. Well, it's not a good window. You might be able to see what's going to happen, though. Let me set my y max higher. Let's put it at like 30. Okay, so there's y1. There's y2. Where do they cross? They don't cross. So this one has no solution. And sometimes you can't tell that when you're starting out problem. It's not that we did anything wrong. I mean, we subtracted 6 from both sides, then we divided by 3 and we squared it. It's just that when we went through the problem, the answer we got is extraneous. It doesn't work. It's because there is no solution. All right, so that's a good example to show you you need to check your answer. So any questions on why the answer didn't work, either graphically, I tried to show you, or algebraically, plugging it back in? Okay. Let's try this one. So this is the cube root of x squared minus 2x plus 2 equals x. Okay. First thing, is the root by itself?
Yeah.
Yep. There's nothing on the outside of that root. You can have as much stuff as you want in the radicand. You just can't have stuff on the outside. So the root's by itself. What kind of root is that?
Cube root.
It's a cube root. So what would I raise each side to? Third power. Yep. So the cube root and the cube are going to cancel out. So we have x cubed minus 2x plus 2 equals x cubed. Now, if the highest exponent there was a 2, it would be a quadratic. And then we could either solve it by factoring or quadratic formula. Is the highest exponent a 2?
No.
No. What is the highest exponent? It's a 3. So this is a cubic. Well, when we want to solve a cubic, we still take the same approach that we would with a quadratic. We want to get it equal to what? Get it equal to 0. And when we get it equal to 0, we generally like the term that has the highest exponent to remain positive. So let's take everything that's on the left and move it over to the right. How would you move the x squared to the other side?
Subtract.
So we're going to subtract the x squared. How would you move the 2x? No, I'm sorry, how would you move the negative 2x? Yep, I'm going to add it. And how would you move the plus 2? We're going to subtract it. So now there's nothing on the left side, and that's what we want. Now, in general, solving an equation that has an exponent of 3 can be a little bit harder, unless something nice is going to happen, and something nice is going to happen here. So we're going to use what's called factor by grouping, which means you look at the first 2 terms, you factor out what you can. You look at the last 2 terms, you factor out what you can. And the hope is that when we do that, we end up with something special happening. Okay. What can you factor out of these first 2?
X squared.
They both have an x squared. If you factor an x squared out, what would that leave you with inside your parentheses? X minus 1. With factor by grouping, the hope is that you get another set of parentheses that have an x minus 1. Okay. What can we factor out of the last 2 terms? They both have a 2. If you factor out a 2, what would be left inside my parentheses?
X minus.
We got an x here, because 2 times x is 2x. And how about there? Minus 1, because 2 times negative 1 is negative 2. That's exactly what needed to happen with factor by grouping. So now you're going to look at that and that. And what do those 2 things that I underlined in blue both have in common?
X minus 1.
They both have an x minus 1. So now you take that out. If you take x minus 1 out of the first one, what's the only thing that's left? Just the x squared. What if you take the x minus 1 out of the second one? Just the 2. Okay. So now we started with something that had an exponent of 3. Now we're down to something with an exponent of 2. Okay, that's going to be much easier to solve. Once we have it factored, we take each one of these and set them equal to what? Set them equal to 0. So figure out what you can plug in that makes the first one 0. And figure out what we can plug in that makes the second one 0. Let's start with the second one. What would be my first step to get the x squared by itself? Subtract 2. So that's your first step. And now, what would your second step be?
Square both sides.
You would square root both sides. Square root, square root. Those cancel. And we have x equals the square root of negative 2. What happens there?
You can't square root of negative.
Right, you can't square root a negative. So that means the only answer here would be imaginary, and we're not concerned about that. So from this part of the problem, there's no solution, nothing we can use. So let's go to the other part. What could we plug in for x that would make the first factor 0? Plug in 1. Okay, so we think 1 is the answer. What do we have to do with that answer?
Plug it back into.
Right. You got to plug it back in because we saw sometimes you get an answer and it doesn't work. Right. So let's plug in 1. What's 1 squared? 1. And 2 times 1? Negative 2 plus 2. What's 1 minus 2 plus 2?
1.
1. What's the cube root of 1? So we get 1 on the left. And now when we plug it in, we're checking 1. What's 1 to the third power? So we get 1 on the right. Are those two numbers the same?
I think so.
Yep, then that works. So that is the answer. Okay, so sometimes solving a radical equation, it's pretty straightforward because you already have the radical by itself. Sometimes you got to do a little bit of work to get it by itself. And then sometimes you have a question where you do all the work out, you get it by itself, and your answer doesn't work. Okay. Any questions on that? Yes?
On the test, was it ever asked to, was the answer ever asked to put an imaginary number?
No, we're just dealing with real numbers.
Okay.
Yeah. Okay. So that's pretty much it. It's solving radical equations. All right, so let me, let's see, solve graphically. Yeah, we've done that one. Okay, so let me adjust the homework. Okay, so that's the homework for tonight. On 255, 11 to 15 odd, 19 through 23 all, and 31. Okay, and you've got just under 20 minutes. So please use a little bit of that time to try to get going on it. I'm also going to put a list of test topics on the board that'll be on the test. And if you have any questions about what I mean by one of the test topics, you can ask me that in just a few minutes.